In today's video, I would like to introduce a very nice problem of Vietnamese Mathematical Olympiad 2004. Here is the following information. Find all triples x, y, z of positive integers such that we have this following equation. We have the product of these numbers. X plus y is multiplied by 1 plus x is multiplied by y equals 2 to the z as a power of 2. Okay. Obviously, this expression is a power of 2 because the right hand side of this equation is a power of 2. We have a kind of symmetry here because just we have the sum of these two numbers and we have the product of the same numbers. Okay, that's mean clearly we have a symmetry here. This is the most important observation. If you would like to give the try to this problem, go ahead, pause this video when you come back to see the full solution. Okay, let's get into the solution now. Without loss of generality, we have x, y, z is a solution, and we have y, x, and z is a solution. Okay, because we have a symmetry. So the second thing, we assume x is inferior or equal to y as a first start. This one will be divided into two cases. This one implies x equal to y, and x is strictly inferior than y. So I'm going to take, when we have x equal to y, if x equal to 1 and y equal to 1, we are going to plug these values into this equation and we have these solutions. Okay, we'll have 1 plus 1 factor 1 plus 1 is multiplied by 1, and we'll have 2 is multiplied by 1 plus 1 is giving us 2. This one is 2 square equals 2z. Now we have found the first solution. We have x equal to 1, y equal to 1, and z equal to 2. Okay, if x is strictly inferior than y, that's mean y equals x plus r. Okay, what is the r? Is some natural numbers. Now if you take a look carefully at this equation, since the right hand side of this equation is a power of 2, that's mean the left hand side of this equation is a power of 2 as well. So that's mean I will have x plus y. It will be written on this form: 2 to the I. I will have 1 plus x y equals 2 to the j. Okay, this will have j strictly superior than I if x is strictly superior than 1 and y is strictly superior than 1. Okay, I'm going to insert this value of y into new equation to see what's giving us. Okay, so x plus y will be replaced with this one. We'll have x plus r, which is 2x plus r is giving us 2 to the I. The second equation, I will have 1 plus x is multiplied by x plus r equals 2 to the j. Okay, now in order to check the parity for the second equation, the right hand side of this equation is even. That means the left hand side of this equation must be even as well. Since this one is even, that means this term is odd, because odd plus odd is giving us even. This is odd. If this is odd, that means x is odd and x plus r is odd, because odd is multiplied by odd is always giving us odd. So that means x is odd and x plus r is odd. If x plus r is odd, implies r must be even, because even plus odd is giving us always odd. Okay, so I know the parity of x and r. Now I'm going to check the parity of y. So since y equals to x plus r, since r is even, x is odd, that's mean y is arithmetically must be odd. Y is odd. Now I know x is odd and y is odd and r is even. This is the information I know. I know x is strictly inferior than y by assumption. I know also the sum of these two terms is a power of 2 to the I. That means the sum of these two terms will be written on this form. So I know three things. I know this. Based on this information, in addition, I'm going to check a few obvious cases here. If you have x equal to 1, which can be written on this form, 2 to the 1 minus 1, and y equals 2 to the 1 plus 1. Okay, I'm going to check x equal to 1 and y equal to 1. I'm going to replace them into origin equation to see what's given us. X plus y, which is 1 plus 3, factor 1 plus 1 is multiplied by 3 is giving us 3. This one is giving us 4. 1 plus 3 is 4, the same as 2 square. Factor 1 plus 3, which is 4, the same as 2 square, which is giving us 2 to the 4th, 2 to the z. Now I found the second solution, z equal to 4. Okay, let's check the second obvious case. So I'm going to plug this information of x and y into the original equation to see is verifying these solutions or not. Okay, so x plus y the same as 3 plus 5, factor 1 plus 3 is multiplied by 5 is 15. 3 plus 5 is 8, the same as 2 to the 3. Factor 1 plus 15 is the same as 6. 1 plus 15 is 16, is the same as 2 to the 4th. We have, that means 2 to the 7, 2 to the z. That means z equals 7 as a solution. So this one is verifying our equation. So let's move on to the next case. If x equals 7 and y equals 9. X equals 7 is the same as 2 to the 3 minus 1. Y equals 9 is the same as 2 to the 3 plus 1. I'm going to plug these solutions into the original equation to see what's given us. X plus y the same as 7 plus 9. Factor 1 plus x, which is 7, is multiplied by 9. 7 plus 9 is a 16, is the same as 2 to the 4th. 7 is multiplied by 9 is a 63. 63 plus 1 is a 64, is the same as 2 to the 6. Okay, it's giving us 2 to the 10 equals 2 to the z. That means it's verifying our equations. I'm going to summarize this one. Since we have these three informations, x, y are odd, and also we know x is strictly inferior than y. We know also the sum of these two terms equals 2 to the I as a power of 2. So since the following solutions are written on the same pattern, first solution is written on the form 2 to the 1 minus 1, y is written 2 to the 1 plus 1. The second one is written on the form 2 square minus 1, y is written on the form 2 square plus 1. Both are odds. Okay, and the third one is written on the form of 2 to the 3 minus 1, is written on the form 2 to the 3 plus 1. I will have a nice form of the solution of this one. So this one is starting as x will be written on this form, x 2 to the k minus 1, and y will be written on this form 2 to the k plus 1. Where is a k? Is the sum natural numbers. I'm going to sum these two terms in order to make sure we have the same form that I will have, because they must be written on this form, the power of 2. So if I'm going to add x on y, x plus y is giving us 2 to the k minus 1 plus 2 to the k plus 1. So number 1 will be cancelled out. So I will have 2 is multiplied by 2 to the k, which is 2 to the k plus 1. Okay, which is 2 to the I. So they are written on the same form. Okay, so that means our solution of this equation will be written on this form. Now we know x equals 2 to the k minus 1 and y equals 2 to the k plus 1 for k is super equal to 1. Okay, now I'm going to find z. What's the general solution for the z? This is the general solution for x and y. I'm going to look for the general solution for z by plugging these two found facts into the original equation to see what's giving us. I'm going to sum this one. X plus y is giving us 2 to the k minus 1 plus 2 to the k plus 1. Factor 1 plus 2 to the k minus 1 factor 2 to the k plus 1 equals 2 to the z. Okay, so minus 1 will be cancelled out. 2 to the k plus 2 to the k is given as 2 to the k plus 1, because 2 is multiplied by 2 to the k, which is 2 to the k plus 1. Factor this one. This one will have 1 plus, I'm going to distribute this one. This is the two different of the squares. I have the factor, this one is written on the form of the product of two difference of the squares. So we'll have 2 to the k minus 1. Okay, this minus 1 will be cancelled out with this one. I will have 2 to the k plus 1 is multiplied by 2 to the k. I'm going to put this one together as one term. I will have 2 to k plus k plus 1, which is the same as 2 to the 3k plus 1 equals 2 to the z. Now I found the solution of x. Now I found the solution of z. That means z equals 3k plus 1. I'm going to write the general solution for x, y, and z. X equals 2 to the k minus 1, y equals 2 to the k plus 1, and z equals 3k plus 1. Okay, this is the first solution. Don't forget we have a symmetry here, because x and y are symmetry for this example. Both of them are odd, so I will switch these solutions. I will have x equals 2 to the k plus 1 and y equals 2 to the k minus 1. Z will be stay the same. Z equals 3k plus 1. Where is a k is a sum natural numbers. Okay, not include 0. This is the general solution for this equation in addition to this solution. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. We will see you in the next video. Bye.